Hey guys, Professor Hughes here again. Watch the following presentation. It's really cool. We're going to go over Newton's methods to solve beats per minute where it equals the inches of the pendulum. Has applications in music more than anything, which is why I even went through this process. Enjoy. Okay, so let's say that you have a graph that has beats per minute of a simple pendulum along the y-axis and the length in inches of that same pendulum along the x-axis. Where do the beats per minute and the inches meet? Okay, there's the graph, beats per minute along the y, inches along the x. And you're going to notice we're pretty close to 52 and 52. Eyeballing it, it looks pretty good. So your data demonstrates that about 52 beats per minute equals 52 inches long on the pendulum. But how do you verify that? And what if you want to be more precise? First, let's explain what has to happen, and then we'll write an equation expressing that in the language of math. To find y, we must multiply x by 0.0254, which is the amount of meters in an inch. The formula I'm using is metric, not the United States customary system. After that, we divide that amount into t, or tau, which is a constant I discovered that takes into account the period of the pendulum in seconds, its beat rate, and the gravitational constant. Now I take the square root of that and we have our y value. This is what it will look like. So we have the function of x equaling the square root of 3577, which is tau, over 0.0254x. So now we need to set up an equation whereby our x's will be equal. And the best way to do that is to set our function equal to 0. So now I have gone ahead and taken our square root, and we're going ahead and subtract the x. What this means is that the x's approach each other, the function gets closer and closer to 0 until we finally get so close that effectively we have a solution that fits. In other words, as our 52 beats per minute approaches our 52 inches, the equation will give us the 0. Of course, plugging 52 into the x will not give us 0. So what shall we do? Shall we plug that 52 in? You'll see the result. So it gives us 0.04044. Pretty close. In fact, at that 0.04044, we are very close. For purposes of music tempo, which is really why I even started looking into this, we couldn't differentiate the beat rate between what we eyeballed and what was demonstrated and what the exact answer is, but let's get more exact, shall we? So to do this, we'll need Newton's method. Newton's method seeks to find the tangent along that graph, which will give us a very precise answer as to as many decimal places as we wish. So our first task is to differentiate our original function, after which she'll need to plug the original function and the derivative into the following formula. So this is Newton's method. He says take your x, and that will equal x minus the original function over the derivative of that function. And then once you have that answer, you go ahead and put that back into the x, and you keep repeating this process until you wind up with as many decimal places as you wish. So let's derivate our original function. Just go ahead and follow along. Wasn't that fun? And here we come up with our differentiation. We have negative 3577 all over 0.0508 x squared times the radical of 3577 all over 0.0254x minus 1. Now we have all that we need. So we're going to plug that into Newton's formula. And there you have it. That's exactly what we need to repeat in order to get what we're looking for. So we can work ourselves into oblivion doing all this math, or we can convert this monster formula into the calculator keystrokes that follow. So I give those to you exactly. Just on my calculator, I just have to insert the number that I'm going to use for what we call the answer, A. Once I have that answer, that becomes our x, of course. So A minus, and then parentheses, square root, parentheses, 3577 divided by 0.0254 A, parentheses, minus A, parentheses. And some calculators have a little A times B over C function. Go ahead and hit that button, and sometimes it puts a little, like, reverse L underneath. Or you can just hit the division sign. It'll work on most calculators. And then hit the parentheses 2 more times. Negative 3577 divided by parentheses again, 0.0508 a squared times the square root of all of this, the parentheses 3577 divided by 0.0254 a, close parentheses, close parentheses, close parentheses, minus 1, close parentheses. All right? Now, be happy you have a calculator, because in the old days they had to do this with a slide rule. All right? In fact, you can see some clumps there. You'll notice that the radical 3577 over 0.0254x, you could actually use that as just a single unit and eventually replace it. But be that as it may, on the third iteration, we land on a number that satisfies our equation because the second and third matched, which means we're getting closer and closer to that many digits. So in the end, we come up with 52.0269542 inches equals 52.0269542 beats per minute. And that's how that's done. Hope you enjoyed it.